Hi, and welcome back to Neural Splendor. Today we're going to talk about an ISL CM2150. That's a mid-range Cummins diesel engine that does have a diesel particulate filter on it. This engine was overhauled about a year and a half ago. It ran fine for a year, and then they had to replace a diesel particulate filter, which was actually ahead of schedule, and they changed it because it was regening frequently. The new filter stopped the problem, or so it seemed. About 3 months later, it was regenning frequently again. And the restriction numbers for the diesel particulate filter were much higher than they should have been. So we had to figure out what was wrong in the base engine causing the problem. We do this through data logs and then examining those logs. So today we want to take a look at, on this particular engine, how we figured out that the injectors were actually the problem. The engine ran like a top, it ran smooth, it had plenty of power, but the injectors were causing our issue. The injectors do not always cause the issue. There's many other things can cause frequent regeneration, and we went through a number of data logs and ECM images and did some tests, but we did find a problem with the injectors, and I want to show you how you can identify using data logs whether or not your injectors could be the problem. This graph represents a half hour of a driving road test. The blue, orange, and gray lines represent the exhaust temperature sensors in the after treatment. The green line represents soot load building in the diesel particulate filter as we drive. It's particularly important to notice in this log that our soot load, or green line, is continually going up as we drive. And it's going up pretty rapidly. So the ECM decides if it needs to regen by the amount of soot load in the filter. So there is a number that we will start the passive regen with. If you notice, when we started the driving log, our soot load was 1.14, and when the log finished, it was 1.2. That might seem like a small amount, but it is significant in this amount of time. I want you to take a look right here. Remember, our brown line or orange line is the heat going into the DPF, and the gray line is the heat coming out of the DPF. You notice how we are not really putting any heat into DPF for quite a bit here, but the exhaust temperatures coming out of the DPF are going up and maintaining a much higher heat output than what's going into the DPF. And this is because we've got a lot of soot going in, and at this point in the log we've reached the temperature where the soot's starting to ignite because there's enough heat buildup. To correct the problem of frequent regeneration, and after looking at the data log and the graph that we just saw, we advised the branch to install a set of PX injectors. Those are Cummins built premium injectors in the engine, and then we did another road test. The results of soot loading were significantly less, as you will see in the following graph. The injectors corrected the problem of frequent regeneration, and now the engine is running as it should. Here we are after our final road test with the new injectors installed. As you can see, the soot load has gone down once the DPF got hot enough to burn the soot that was in it. That's the gray line there. You can see how elevated it is. That's where the soot was burning out, and then it goes down significantly, and our soot load goes down and it stays down. That's what should happen if the engine is running correctly. Our new injectors are atomizing fuel properly. There's not a lot of smoke, if any, exiting the exhaust ports, so the engine is back to running as it should. This graph represents what you should see in a good running engine.